Hello, welcome back to my channel. In this video, I will explain one of the fundamental concepts of the object-oriented programming. It is called solid principles. Before we start, make sure that you are subscribed to my channel for more videos. By the way, you can get your free cheat sheet about solid principles in the description box by subscribing to my newsletter. Okay, let's start now. There are 5 solid principles. These are single responsibility principle, open-closed principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. Now I will elaborate each principle. Single responsibility principle. A class should have one and only one job to be responsible for. Here you see 2 class designs. The one on the left is an example of bad design because invoice class has also send email function, which breaks the single responsibility rule because sending email and generating invoice are totally different jobs and they must be separated. The design on the right hand side contains 2 classes which have one and only one responsibility. For instance, you can send emails without having to generate an invoice class on the better design. Open-closed principle. Classes should be open for extension but closed for modification. In the bad design, the code must be changed if another type is added on the system. However, in the better design, it is possible to add new discount types without changing the existing code. Liskov substitution principle. Subtypes should be substitutable for their base types. According to the Liskov substitution principle, the design on the left-hand side is wrong because penguin and bird classes are not interchangeable due to the fact that penguins cannot fly. However, the design on the right-hand side is valid because penguin class doesn't inherit the fly method, avoiding breaking the principle. Interface segregation principle. Classes should not be forced to implement interfaces they don't use. Avoid creating large interfaces with methods that may not apply to all implementing classes. In the bad design, the principle was broken because the robot class had to inherit the eat function, which it is not capable of. But in the better design, work and eat functions are introduced in separate interfaces, and this allows the classes to implement the necessary interfaces. Dependency inversion principle. High-level modules should not depend on low-level modules. Both should depend on abstractions. Here in the better design, application depends on the iLogger abstraction, not a concrete implementation. This allows flexibility to use other loggers like database logger without modifying the application class. However, this is not possible in the bad design. That's it. I hope you enjoyed the video. Like the video and subscribe to my channel. Also, do not forget to get your free cheat sheet in the description box. See you in the next video.